So, first of all, thank you very much for inviting me to talk. I'm conscious I'm the last one on. So, it's the last opinion piece or last set of observations. The last 2 days have been amazing, I think. I'm sure you all feel the same. So it's a great honour to be here. I'm conscious too that being the last one, actually a lot of the points or subjects I'll touch upon have been raised, at least so far. And I suppose it's my aim to try and shed the light of my experience on those subjects. I'm trying to be as objective as possible, and that's my aim. So I'll try and do that for you. And I'm especially conscious to try and express or explore kind of the bandwidth of both the people that live in these buildings that we're talking about, and there's been a lot of focus on fabric and windows and widgets, and perhaps rather less said about building occupants. And there's been, I think, for me, a general sort of drift towards seeing all historic windows in one kind of box. And for me, I see them very much as a very wide sort of spectrum of different things. Okay, so those are some of the themes I'll try and cover. In terms of the structure of what I'm going to say, I'm going to say a little bit about who I am, not because I like talking about me especially, but I think it's important to sort of understand the context of where I'm coming from. I'll explain why I think windows are especially important to the things I do. And then I'll whiz through 4 examples of approaches that we've tried, and I'll then try and reflect upon how successful those have been from different angles. So both from an energy efficiency perspective, a usability perspective, longevity, and even sort of trying to relate back to significance, which was spoken about yesterday and is essential. And then I'll try and summarise at the end, hopefully, and it might make some sense if I'm very lucky. So a bit about what I do. So this is a range of buildings that I've worked on over the last 15 years or so. So I'm an architect by profession. I've also worked on building sites in the past. I'm a passive house designer. That's the only the second person who's put their hand up to have that qualification. Might be a bit dubious to some people here. And also spend a lot of time writing heritage impact assessments as part of some of the work I do. So you can tell that some of the buildings here are listed. Some of them are conservation area, and some of them are seen as much less significant by our society. For me personally, with every project we do, I kind of see significance in all buildings, even the most lowly, the most common, and sometimes the most unloved. Part of what I do as somebody who's interested in retrofit is to try and enhance buildings often as part of sort of architectural projects, enhance their energy efficiency. So these numbers, this metric of space heat demand, is where the buildings started off when we found them, or this is our best assessment. And the numbers on the right in darker colour are where we think we've left the buildings. And some of those have been studied, and POE can back that up. And the general point I'm trying to make is that the grey numbers are generally quite big, however well you sail those ships, and the black numbers are much, much smaller. And actually, some of the oldest buildings there end up doing the best. because their form factor is quite good, and some of the more modern buildings that you might expect to be more kind of retrofittable remain quite hard because of their shape and their form and other constraints. So for me, I'm a pragmatist, and I seek to do as much as I can. I don't seek perfection in any kind of the elements that I'm following, but I'm trying to seek balance. Hopefully, that's my aim. And on the energy front, I'm relatively ambitious, I suppose, because I think we have to be relatively ambitious. A quick whiz back to comfort, and this isn't a perfect expression of comfort, and there's a whole lecture about comfort, and Robin took us through quite a lot of really important points this morning. But for me, in terms of windows and single glazed windows and why they do present a bit of a challenge, is so this person's sat in a room at 20 degrees ish, which some people think is approximately comfortable, to be debated. Outdoors, it's winter, it's 0 degrees. So the internal surface temperature of the glass is going to be almost like the outside. You've got cold air drifting down off that glass, especially if it's a large Georgian window. You've got drafts coming in around where the window doesn't fit very well in its masonry surround, where the moving elements perhaps don't fit very well. So, drafts and radiant coolth are two sort of prime reasons why it's quite difficult to establish comfort in buildings with lots of glazing. Even if you've got the boiler running quite hard and radiators running quite hot, and you also get this sort of other problem of temperature asymmetry, especially in small spaces where one side of you is being heated by a radiator and the other side of you is being cooled by the window. I've definitely lived in small flats in London like this, and I'm delighted to say I no longer have this going on. And indeed, I can turn the thermostat down a bit now, because without the drafts, comfort's much easier to establish, even without especially high internal air temperatures. So it's perhaps a bit more long-winded than I'd planned, but for me, understanding comfort and how we achieve that with energy efficiency, how those two things can go hand in hand, is really important. This is another imperfect representation of how uncomfortable a particular space is and how hard it is to sort of manage. So this is an internal temperature plot of the space I work in, which is a small sort of floor plate in a listed building with windows which have been rather unloved for many decades. So we suffer with the draft, we suffer with the coolth, because it's a small room, we sit quite close to the windows. And we use radiators to try and offset the very strong discomfort when we come in on a Monday morning by raising air temperature. But you can see, whatever we do, the temperature's sort of moving around quite a lot, which doesn't help. And it rarely sort of sits anywhere close to where me or any of my team would say it's particularly great. And all my team come to the office because they want to do something about buildings and our environments, and they sit there all winter in duffel coats and scarves and fingerless gloves, so that we're not wandering around in boxer shorts here, but we really struggle. And I'm delighted to say our local authority have given us permission to interfere with the windows in the listed building we work in. U values have been discussed quite a lot. This is some of my sort of take-homes on U values. So most buildings, I find their elements, the roof, the floors, the walls, even before we do anything, the U values are sort of small whole numbers, less than 2 normally. And usually the loft has got a bit of insulation in, so that's probably below 1. Whereas the windows, if they're single glazed, as you've heard, if you didn't know before the last 2 days, you very well know, up at sort of 5-ish, between 4 and 5. So as a result, there is the potential to make big inroads to buildings with single glazing, especially if the glazing proportion's relatively high. Obviously, if it's tiny windows in a cottage, that potential's reduced much, much, much more. So for me, windows I find especially opportune as a means of reducing heat loss and improving comfort and avoiding the condensation and so on and so on. Another sort of bandwidth table on the U values, and 2 or 3 people have shown similar slides. Not sure any of our slides actually match each other completely. Okay, this is my experience and sort of my feel a bit, so it's not 100% scientific. But single glaze, definitely up there in the 5s or 4s. Ordinary secondary glazing, probably getting down sort of into the 3s, into the 2s. Some people have been as ambitious as suggesting below the 2. I'm possibly a bit sceptical. But that sort of zone, sort of good double glazing, which I mean sort of fat double glazing, between 2.5, maybe into the low 1s. But then what I'd call advanced secondary glazing, so this is secondary glazing with double glazing in it, or vacuum glass. You're starting to approach the 1s. Vacuum glazing in secondary towards the 1, with the latest generation of glass possibly below that. And then, passive house, probably quite chunky windows below 1. Okay. So for me, the observation I take from this is that if we could do any of the last 3, in reference to the previous chart, you can make really big inroads into heat loss for buildings with largish windows, so most Victorian buildings, most Georgian buildings, which is mostly what I tend to work on because of their ubiquity and because of where I live. I'm really keen not to sort of pick one horse. And I think there's a general drift I feel, especially in the listed building world, towards secondary, because quite a lot of us can agree that it's a reasonable balance. But I'm not sure that's always the right path for listed buildings, personally. This particular project, it's a conservation area project where the approach was based on sort of understanding the condition and the significance and a general understanding of the windows in this house. So the top windows already been replaced in the 80s, and those windows are rotting out. So we replaced them with, modern, relatively economic, fat double glazed units, fatter mid-rail, some plant-on bars there. So not especially fine, but they're sort of quite high up. They're less important, I think, than the other windows. And certainly what we found before them was not so amazing. The windows in the middle, our client really loved them, but so they were Victorian windows in pretty good condition. The glass had a wonderful quality to it. So those are fitted with a simple secondary glazing system. So it's a double system, so it qualifies my sort of advanced category. And then on the ground floor, the boxes were okay. They were salvageable, but the sliding sashes were not. So we replaced the sashes with double glazed, and because they were 1/1s, we could get a reasonable bit of double glazing in there with a reasonable performance and a reasonable longevity. So this is partly about this project, but it's partly about actually kind of trying to see as wide a variety of solutions as possible. So this is the first of the 4 sort of mini case studies. They're not very long, and I've saved you the sort of hundreds of pages of heritage impact assessment on some of these, but we spent a lot of time trying to understand these buildings. So our client's house is the one behind the green car there, so almost in the middle. So quite a fine bit of Georgian streetscape, just before 1800. I should put a shout out to Charles, who's been there. He's been to other buildings with us, at least 2 in this presentation, who helped us understand what had gone on in this building. So, in the Edwardian period, probably like its neighbour, somebody thought it'd be a really clever idea to take the shutters out because they were sort of old and fusty, win back a bit of space by removing the false wall which hid those, and put in modern glazing with big panes of glass. And there's a whole argument which the neighbour ran into 6 months after us about is that a really important part of the story of this building? And I'm not going to go into that one today. But our client, at least, was really keen to return this building to its former glory, shall I say? And we felt that was a potentially reasonable thing to do. If we felt we could work other things into it. So this is an example of one of those windows. Probably one of the worst or the most damaged floor, actually. So quite a lot of fabric had been lost. The boxes were Edwardians, and the sashes were in quite poor condition. And you'll see in a moment, if I skip to the next, that's what it looked like sort of over 100 years ago. There was a whole set of shutters there and a false wall which had been taken out. And interestingly, they'd extended the skirting 20 centimetres and they'd moved the cornice to sort of hide all of that. That's sort of where the story might have been lost a bit in what we did. In any case, we've reversed it. This is a restoration. This is rather than a conservation project, perhaps. But in the process of reinstating the shutters, we included secondary glazing, which you can see in the image there, because we've pushed up the lower sash. So most of the meat of the secondary is hidden by the reinstated shutters. And this felt at the time like a reasonable trade-off to me in terms of transforming the energy efficiency of the house and meeting our clients' desires. And it was also an interesting sort of exercise in understanding what had gone on and how we might borrow the details from the Dickens Museum down the road and bring it back up the street. And this is the sort of assembly process that we planned. So the pink and purple stuff is things which we adjusted or took out and adjusted and repaired. And then you can see the secondary glazing going in and the shutter boxes being planted over the top. And then the false wall going in over the top of those and a cornice being reinstated. So that that's one example based on quite specific starting point. The secondary glazing here was double glazed, so it's sort of pretty high performance. The overall window is about sort of 1.2, 1.4, perhaps a bit better than that. I think I'm being fairly conservative. And we've checked the sort of build data after the project, and the windows alone here, the client didn't invest in many other fabric measures apart from sort of roof insulation, but the windows alone were making about a 30 to 40% difference on the heating demand. And the client's very pleased with the sort of level of comfort they got and the stability within that house. It was quite a substantial bit of work to do that, to make the shutter boxes and so on. And I might return to that later on. So that's the first one. And I've probably got about five or so minutes left. I think I started a bit late. So the second one, it's quite a similar result, but slightly different starting conditions. So a house further down the road, actually, slightly finer house, more original details, some original windows, some Victorian windows. Most of the glass had gone due to World War II. And in this one, there were shutters in situ, albeit painted shut and quite damaged. There was bits of rot, quite a lot of rot in windows. And the solution was to take all of that apart, rebuild the shutters and rebuild the windows, and again, insert this secondary glazing between those two elements. So we've interfered with a bit of original fabric, but we felt we were justified because we felt those jobs needed doing anyway, and it opened up the opportunity of including this glazing, which again transforms the house. We also insulated behind the shutter boxes and within the false wall. Quite a complicated process, even on the drawing, but yeah, on site, quite a lot of fine carpentry going on. On ground floor, we ended up doing something slightly different. We had quite a fat staff bead, and we managed to fit in a very skinny secondary casement with evacuated glass again. There it is there. So, I think for us, it took a lot of convincing the conservation team that the impact of this was minimal, but it's there, and certainly anybody who looks at it in detail, finds it. So with this one, probably you window down perhaps as low as 1 because the glass was slightly better. Again, heating demand reduced by about 40% just through windows alone because of the large glazing area. This enabled the installation of an air source heat pump, which further decarbonises that house. Especially good comfort because it's done in conjunction with insulation. But yeah, a very extensive work. So the third one is a replacement of a replacement. So a bit like the first windows in the earlier slide. So 1980s sashes replaced with higher quality ones, in this case using slim double glazing. So this was back in 2010 before Evacuated had really made it to the marketplace. Big upgrades in terms of air tightness because of the way the window's made. It's quadrupled stripped and fairly big difference on the U value. But sort of mid U values and declining as the gas escapes, but it actually seems okay so far. Lots of edge seal, so more concern because each pane is individual. So you've got many sort of linear meters of edge seal per window. And you've got the argon and krypton with their high embodied carbon, which other people have spoken about. So I think at the time, this felt like a good solution. Feels, for me, less so now, which takes me on to number 4. Again, this is a replacement window of a replacement window in a conservation area. So we were able to, do this without too much justification. So there's the window. Aligned with internal wall insulation. That's it looking from the inside. I'm deliberately using the word authentic here because, it's a much contested word. And for me, in houses like this, I think the appearance in terms of the general streetscape is probably the most important thing. And what this gives you, even close up when people visit, certainly people not from this audience at least, more sort of lay people, they're not aware that this is high performance glass. They think it's a single glazed building. So there's this sort of appearance of single glazing. The panes are 1 per sash unit with plant on bars, but you're not really aware of that. The edge seals are much fewer, therefore, so there's much less thermal bridging, there's much less chance for degradation. U value sort of down to sort of 1, so very good. The noble gas is not there. And And this is relatively straightforward to do. So returning to the case study 1, that listed building, where the windows had already been replaced and much change had already taken, I wonder if this sort of solution might have been appropriate there. I mean, I sort of believe it would be, but how I might get that past the conservation team in that borough would be the question. So a few concluding thoughts on my sort of journey through windows in the last 10 or so years. So window upgrades are enormous chances to transform heat demand in buildings, and arguably to enhance character and significance if that's done quite thoughtfully. Both U-value and air tightness improvements need to be thought about at once. So, one of the challenges with just upgrading glass is we're not really necessarily improving the overall air tightness of windows, which George and Sash windows weren't fitted with air tightness in mind. I'm not sure they were fitted with draftiness in mind either. It was just the way they were built. Window upgrades can be, discrete in terms of there's only one thing going on and you can contain disruption. It can be done relatively quickly. High performance, I would argue, can be achieved with little harm. Window upgrade should always be coupled with ventilation improvement. And that's something which has been touched on a bit, but I think is essential. And actually, if you can get quite a lot out of the windows, you may need to push less hard on other fabric measures, such as internal wall insulation. So that first case study, it still did quite well, even though the only real retrofit work we did was to the windows, where the client was already going to spend quite a lot of money anyway. So an internal wall insulation in parts of the UK fills me with this special sort of fear because of the moisture problems and other attendant issues and the massive disruption to people and significance. So these upgrades can potentially enable air source heat pump viability, which, the two together, the effect is massively decarbonising. But the one without the other, certainly the air source heat pump alone, is probably quite a difficult thing to do. It probably means very big radiators, quite a big bit of kit, probably quite difficult to manage. So as part of a whole house plan, that's something I've not spoken about today, I don't spend most of my life speaking about. Windows can really support and allow deep retrofit, deep decarbonisation. Finally, quick reminder, I always show this slide, overall in the UK, 62% of our energy use in dwellings is due to heating. That's just a reality. We really need to change that. And this is a plug for a different cause, but the one of rolling out decarbonised heat that needs to happen very, very, very quickly. And I see windows as an enabler towards that. Thank you very much.